Welcome to this predicted paper from onmaths that is based on the advanced information given to us by the exam boards. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. The first thing to do when working out what angle things need to be on a pie chart is to add up the frequencies. So we're going to do 14 plus 7 plus 3, and we find out that that's 24. Then we're going to find the angle that one item would be. So one item is going to be, well, there are 360 degrees in a triangle, and there are 24 items. So we're going to do 360 divided by 24. And that gives us 15 degrees. So each item is worth 15 degrees, or will take up 15 degrees. So to find out the angle for red, well, we've got 14 items, times it by 15, and that will give us 210 degrees. And we're just going to times each of these by 15, which would be 105, and the final one times 15 is 45 degrees. Add them up and they add up to 360, which is good. They need to add up to 360. So we get our protractor, rest it on a pie chart. Now we know 180 is down here, so the first thing we're going to do is just mark that on, because the first angle is going to be 210. So we know that's 180 so far. So I'm going to turn my protractor around, and from 180, 210 will be another 30. So I'm just going to plot that on. And then I'm going to join it up. So start at the center and join that up. And we're going to stop when the circle stops. Then to do 105, we're going to put our protractor in the middle. And we're going to look at 105, which will be up here. And then we're just going to join it up with a straight line. And then we're just going to check the last angle. And so if I put my protractor on it, and it is 45 degrees. Perfect. Now, an important step to not miss is you need to label them. And so the first one is red, the second one is blue, and then the final one is other. So firstly, we're going to work out what the percentage increases are as a multiplier. So we start off with 100%. Jane has a 1.2% interest pay rise, and so that would be 101.2%, and we divide that by 100 to make it a multiplier. So the multiplier is 1.012, so we get the 20,000 times it by 1.012, and that gives us 240. Next we do the same for Lenny, so that is Jane. And so let's do Lenny. And so that's 100% plus the 1.5% will be 101.5%. Make that a multiplier, 101.5%. We divide that by 100. Which give us 1.015, and then finally what we do is we get the 17,000 times it by the multiplier, and when we do that we get 255. So Lenny has 255, Jane has 240. So it says which of the employees has a larger pay increase and by how much. So the answer will be Lenny, and it's by £15, because that's the difference between these. For mutually exclusive events for A and B, the probability of A or B is equal to the probability of A plus the probability of B. Now we're given the probability of A or B, which is 0.36, and we're given the probability of A, which is 0.12. And so to work out the probability of B, all we need to do is going to solve this. We're just going to take away 0.12 from both sides. And that will give us 0.24 is equal to the probability of B. So B must be 0.24. It only works if A and B are mutually exclusive though. We're going to start off by writing the numbers that the dots are at. So we've got -12 and we've got -5, and x is anywhere between those. Now it's obviously going to be greater than -12 and it's going to be less than -5, but it can equal -12, and the reason for that is it's a filled in dot, but it can't equal -5 because that is a hollow dot. We've got to first of all work out how many parts there are altogether in our ratio. So we've got 51 saying yes, 7 saying no, and 13 undecided. So altogether, we've got 51 plus 7 plus 13, which is 71 parts. Now each part is equal. So to find out the value of one part, we're going to do how many students there are, which is 2,911, and divide it by the 71 to find out what one part is worth, how many students are in one part. One part's worth 41 students. So each one of those parts in the ratio is 41 students. Now yes, because it goes yes, no, undecided, yes will be the 51 there. So it's 51 lots of 41 students. 51 parts with each part representing 41 students. And when you multiply those together, you get 2,091. So our answer is that 2,091 students responded with yes. So to find the area of a rectangle, we just multiply the width and the length. So that's what we're going to do here. But whenever you have an expression representing a length or a width or anything really, you just put brackets around it. So we go u minus 2 times u plus 9. Okay, and the way we do this is with our grid. And I'm just going to draw out the grid. And so we've got u minus 2, and we're multiplying it by u plus 9. Don't want too many for some reason. And so we've got u times u, which is u squared, u times minus 2, which is minus 2u, 9 times u, which is 9u, and 9 times minus 2, which is minus 18. And what we're going to do is we're just normally going to be able to add these ones together. So our answer will be u squared, and then we're going to do 9u plus minus 2u. Well, that's just going to be 9u take away 2u, which is 7u. So plus 7u, and then minus 18 at the end. We can rewrite this question as 2 over 3 divided by 20 over 1. So whenever you have an integer, it's just the same as that integer over 1. Now the rule is that we're going to keep, flip, and change. So we're going to keep the first fraction as 2/3, change the divide to a times, and flip the second fraction. Then we multiply the tops and multiply the bottoms. We can actually halve top and bottom here, and it does ask us to simplify it if possible. So our answer is 1 over 30. To find the mean, we need to work out the sum of the numbers, basically what they add up to. And what we then do is divide that by the amount of numbers. Now, what this table is telling us is there are 14 students who got a time between 0 and 4 seconds. Now, it's absolutely impossible to work out what time those students got with the information in this table. So what we need to do is we need to assume they all got, say, 0 seconds or all got 4 seconds. And the fairest value to say that they all got is what we call the midpoint. And to find the midpoint, what you do is you add up the lower bound and the upper bound, so the highest value and the lowest value, add them together and divide by 2. So 0 plus 4 divided by 2, which is just 2. And that gives us a halfway number, which is fair to everyone. So the students roughly probably got 1s, 2s and 3s, and maybe a few 4s maybe. And the average of that is going to be 2, so that's fair for everyone. Same with the 4 and the 8. Halfway between 4 and 8 is 6, and you can add them together. 12 divided by 2, which is 6. Go down finding the midpoints, and we're just going to assume the students all scored the same amount, all got the same time. Then we're going to do our FS column, okay? And so we're assuming that 14 students got a time of 2 seconds. So when you times those together, you get 28. And we're just going to times all of these together. Okay, next we're going to work out the sum of the FS. And to work that out, we just add all of these up together. So we're going to do 28 plus 36 plus 30 plus 126 plus 36. And when you add them all up, you get 256. Now, that will give us the sum of numbers. So we're going to put that into our working out now. And we need to find out how many numbers there are. Well, the frequency column will tell us how many numbers there are. So we're just going to add all of those up together. So we're going to find the sum of the frequency, which is 14 plus 6 plus 3 plus 9 plus 2, which is 34. And when we do 256 divided by 34, we get 7.529 blah blah blah. It says it wants it to 2 decimal places, so we're going to round it to 7.53. To convert from meters to centimeters, we times by 100. But here we're asked to convert between meters cubed and centimeters cubed. So we times it by 100 per dimension. Meters cubed and centimeters cubed is volume, which is 3 dimensions. So what we do is we times it by 100 3 times, times 100, times 100, times 100, or times by 100 cubed. So we get our amount, 0.15, times it by 100 cubed, and that will give us 150,000. So our answer is 150,000 centimeters cubed. To find the force, we need the pressure and the area. We're given the pressure in the question, so all we need to do is find out what the area of this circle is. And the formula is pi times r squared, which will be pi times the radius, which is 5 squared, which will be 78.539 blah blah blah. The formula for pressure is pressure equals force divided by the area, and we rearrange that to force equals pressure times area. Pressure, it says, is 0.1512. The area we found out in the previous question, and we keep that in our calculator, so we keep the accuracy up, and when you do that, you get 11.875 blah blah blah, rounded to the 2 decimal places it asks for, and you get 11.88 newtons. There's a lot going on with this question, so I'm going to start off just having a look at the total amount of money. So I'm going to do this in pence, so 2115 pence. And if each merit point is worth 3 pence, then we can work out the amount of merit points by doing 2,115 divided by 3. So that gives us 705. So there's 705 merit points. Next, have a look at the question here, this part here, where it says James has X merit points. Sarah has 4 times as many points as James, so she's going to have 4x. Robert has 69 fewer merit points than James, so he's going to have x minus 69. And we know that that equals 705 because we've just worked that out. And this feels like a solving coming on. So we've got x plus 4x plus x, which is 6x. Minus 69 equals 705. And we're going to add 69 to both sides. So we've got 6x equals 774. Then we're going to divide 6 both sides. And so we've got x equals 129. So x equals 129. That means James has 129. Sarah has 4 times more, so she will have 516. And Robert has 69 fewer, so we're going to take 69 away from that, and that will equal 60. First thing we need to do is work out the volume of this prism, and it's a trapezium-based prism. So the volume will be the area of the cross-section, or area of the trapezium, times the length, how 3D the prism is. So trapezium is half a plus b h, and then times the length. Now a and b are the two parallel sides, which will be this one and this one. And then the h is the perpendicular line that hits both of them at 90 degrees, which is what perpendicular means, between the bases. So this will be the 25 meters here. So it's going to be half, and then we're going to add 1 and 5, times that by 25. The length is how 3D it is, so it would be that 10 there. So we're going to times that by 10, and that will give us 750. So it's 750 meters cubed. Now, there is a little formula we can make for the rate. So the rate of anything for this will be the volume gained over time. Now, with this question though, we're interested in the time it will take. It says how long will it take. So we're actually looking at the time. So it will be time equals the volume, which is 750, over the rate, which is 15. So 750 divided by 15 is 50. So it will take 50, and let's have a look. It says per minute, so it would be 50 minutes. This question relies on the fact that you know what the equation of a circle is. And the equation of a circle is x squared plus y squared equals r squared. Now r is the radius of the circle. So when I rewrite this, and I write it with our 16 there, we can actually rewrite 16 as 4 squared. Okay, comparing this equation to this equation, we can see that r is 4. Now this equation, the x squared plus y squared equals r squared, gives a circle with the centre at 0, 0, at the origin. So it means that the radius will be 4, so the circle will go all the way up here, all the way across here, all the way down here, and all the way across here. Now, I am really, really bad at drawing circles, and so what I would recommend you do is use a compass and measure out 4 and join these up. I'm going to try my best. I don't have a compass that works with this graphics tablet, but I'm going to try and draw somewhat of a circle. There we are. That's probably the best circle I'm going to draw. So what you do is you just get a compass and put the point at 0, and then you would measure out 4 units. So measure it between the 0 and the 4, and then just draw a perfect circle round. Capture-Recapture is a way of estimating total population sizes, and it uses a really nice formula, which is n equals little n times little m over big M. Now, n and n, the little ones, are are sample sizes. Okay, so they're the size of each sample, and this big M here is the amount that were marked in the second sample. Okay, so n is the first sample, m is the second sample size, and then m is marked. So marked in the second sample, because obviously you're going to mark all of them in the first sample. So what you do is you catch an amount of a trout in this case, mark them all with any kind of marking, and then you capture again, and capital M is the amount that were marked from the first sample in your second sample, and then capital N is the estimated population size. So that's what you think the overall population size is going to be. So here we caught a sample of 84 and tagged them all, and then we released them. Then we caught a sample of 56, and we found that 15 were tagged. And so when you do the sums on that, it's going to be 313.6. And when you round it to the nearest integer, because obviously you can't get 0.6 of a trout, we estimate it to be 314. To find the length of the rectangle, what we're going to do is we're going to get the area and we're going to divide it by the width. Now, the question says that it wants the minimum length. So we want the length to be as small as possible. Obviously, to do that, we want the area to be as small as possible. If the area is smaller, the length will be smaller. But let's have a look at a couple of fractions. So let's have a look at a half and 1 over 100. Which one of those fractions is the smallest? Well, it's 1 over 100. But what do you notice about the denominator? That as the denominator gets bigger, the fraction gets smaller. So to make something smaller, we actually want the denominator to be as big as possible. So we want the width to be as large as possible. So we're going to find the lower bound of the area. And an easy way to find a lower bound is find the accuracy. Well, it says the accuracy is to the nearest 10. And what we're going to do is halve that. So half of 10 is 5. And then we're going to take it away from the area. So it's 98,540, take away 5, which will be 98,535. Now for the width, we're going to do the same thing, half the accuracy, half of 10 is 5, but we're looking for the upper bound, we're looking for the biggest it can be. So we're going to add that on, 1, 2, 3, 5. And when you do that calculation, you get the answer of 79.78542, blah, blah. And it says it wants it to 4 decimal places. So we're going to do 79.7854. To find the inverse, we're going to, first of all, instead of writing f of x, I'm just going to replace it with a y. And the trick of finding the inverse is to swap over the x and the y. So we're going to swap them over. I'm just going to do it over to the right hand side over here so we've got a bit of space. Now the challenge is to get it so that it's y equals rather than x equals. So we're going to start off by multiplying both sides by 4. And that will give us 4x on the left hand side, and it will get rid of the fraction on the right hand side, which was kind of the point. Next we're going to get rid of that minus 6, so we're going to add 6 both sides. And then finally we're going to get rid of that times 5 there by dividing both sides by 5. So we've got 4x plus 6 over 5 equals y. And we use y as a replacement for the inverse function of x. And so we're just going to say the inverse function of x, which is what that minus 1 means. It means inverse, equals 4x plus 6 over 5. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.